Okay, today is May 13th, 2011. You guys are on text page 342, Blue Notebook page 403, and we're on lesson 7.2. So yesterday we were doing similar triangles. Today we're going to actually solve problems using similar triangles. So, they've given us a long explanation, for example, one about two trees being across a river from each other. I think there's a young lady standing here. Let's draw her. Her arms, her wavy hair. She's standing there, yeah. Okay, and she's taking some measurements. From where she is to point, this is an A, is 8.4 meters. From where she is to point B, she's 9.3 meters. Find the width of the river using the information that Naomi found. So, the river in the question, this is one side of the river, and this is the other side. Okay, so we're trying to find the width of the river, which means this is my x. From the maple tree to the willow tree, I need to find the distance. Now what Naomi created is she created, well, first of all, are these triangles congruent? No, they're definitely not the same size. They may be the same shape. In fact, they are the same shape, just not the same size. So that means these are similar triangles. She was trying to find the distance from the willow to the maple. So what she did is she put two stakes in the ground at A and B and put herself at a point to create a similar triangle to the one formed over the river. So if you think about it, really the only information she had is she wanted to find this distance here. Okay? So what she did is she stuck this stake in the ground and another stake that was in line with the willow and B, and then she stood at a point. She made sure that where she was standing created a parallel line with what the willow and maple was. So she created a similar triangle in order to measure distance. So essentially what this idea is trying to show you that if you have a couple objects and a few tools for measuring, you can find distances of other areas all around you. You'll eventually get what we're talking about. But okay, so we need to find the width of this river. First of all, we know these are similar triangles. If they're similar triangles, that means, I won't draw this yet, that all of the angles are going to be what? Yeah. So the angles in triangle AB girl, as we're calling that point, are equal to the angles in, we'll call it maple, so M, willow, and B. Sorry, I forgot to put triangle. So the angles in triangle AB girl are equal to the angles in triangle M for maple, W for willow, and point B, so that's stake in the ground. So we know the angles are all going to be the same, and if we look at it, what's this angle rule called here? We have a Z pattern, alternate. So because this is at a 90 degrees, we know now that the angle where the girl is going to be 90 degrees. Okay? We can't actually figure out the other two without some trig ratios. So what we're going to do is just find the distances now. Now, if you guys remember, we were talking about scale, the scale of a triangle. When we have similar triangles, there is a scale, so the amount you'd multiply one triangle's length by to get the other triangle. In the book, today they've called it scale factor K. Okay? So make sure you guys have that down. Scale factor K. What that means is they want to know how much you have to multiply one triangle by to get to the other triangle. Okay? So now we do have some similar sides. Does anyone know which two sides of these triangles are going to correspond with each other? Okay, what about WM? What side of, we'll put the triangles in two different colors here. We have green triangle, and we'll have the red triangle. What part of the green triangle relates to willow and maple? Daniel. Girl in A. That's right. So this part here will be a scale factor of this part of this triangle here. So let's try to set that up. We're going to try to set these ratios up now. We're going to name the girl, we're going to call her C, okay? So it's a little easier. So we have angle C, line AC is equal to line MW. Sorry, not equal. Those are going to be our scale factors. I don't know why I wrote equal. MW. Okay, so we're going to divide by it, and I'll get rid of the lines on the top. We just know that there's 2 points. So let's divide it by. So we know that AC is a distance of 8.4, and MW, well, that's our X. That's what we're trying to find. So that's one side of the triangle. So we're going to call that side 1. Side 2, what part of the red triangle corresponds to side AB of the green triangle? We have AB, which part of this red triangle is related to that? BW, that's right. So we have line AB over BW. Do we have either of the distances of those? No. I'm just going to call it, sure, call it Y over Z. We don't have any of those distances. And finally, that leaves us with these only our last two from calling this point C now. CB means it must be related to BM. So CB, BM. The length of CB we have 9.3 meters. And the length of BM is 24 meters. Okay? So what we need to try to find is we need to try to find a scale factor for this question. We need to figure out how much we multiply one side of the triangle to get to the other. So it can actually go both ways. I can try to figure out how much I need to multiply the green triangle by to get to the red triangle. Or it could be the opposite. I have to figure out how much I have to multiply the red triangle by to get to the green triangle. We'll start with the easier idea. We'll start with going from the green triangle, so triangle ABC, and what scale factor we have to multiply by to get to the red triangle. So with that idea, what I want you to do is these two numbers are very important. We need to figure out how to get from 9.3 and what we're going to multiply 9.3 by to get to 24. So in other words, I can actually make my own little expression on the side. Okay, I'm going to do it in red. What I'm trying to find is 9.3 times some number, we'll call the number n, equals 24. We know that we have to multiply by this number. Oh, sorry, why did I call it n? They're calling it k, so let's call it k. This is our scale factor. Okay, 9.3 times our scale factor, whatever it is, gets us to 24. So how could I solve for this? What would I do? Divide both sides by 9.3. So our scale factor, k, is going to be, okay, so it turns out it's going to be 2.58. So our scale factor is 2.58 for this entire triangle. What that means is I multiplied 9.3 times 2.58 to get to 24. Okay? All right, well, with that being said, we need to solve for our x. So in other words, I need to take, this is our green triangle again, the 8.4. And what do I need to multiply it by? Our scale factor, 2.58, to solve for our x. So in other words, x is going to equal 8.4 multiplied by 2.58. Let's figure out what that is. Okay, so 8.4 times 2.58 is 21.672. So it turns out the distance of this river here, our x, is 21.272 meters long. We use that by using our scale triangle. Now, what if I wanted to do this the other way? What if I decided, I'm going to do CB again. So we'll do the same side. What if I had CB by BM, 24, we have still the same ratio, 9.3. What if I decided I want to go from the red triangle to the green triangle? So in other words, what do I multiply 24 by? I get to 9.3. Anyone know how I could set up that algebraic expression? Say it again, Irvin? Yes. So in other words, I would have set it up the exact opposite way. 24K is equal to 9.3. Okay? So same idea. I solve for K, divide both sides by 24 to isolate K. K equals what is it? 0.3875. Okay. So take a look at that. Okay, we have our new K factor. So the K factor technically changes if I'm going from a larger number to a smaller number, or sorry, from a larger triangle to a smaller triangle, or if I'm going from a smaller triangle to a larger triangle. Let's just check to make sure. Let's figure this out. If I multiply 21.672 by our scale factor, so we're going from the red triangle to the green one. Oh, I do that way too small. Can you just tell me the number again, please, Darren?
0.3875.
Okay. Equals, and we know it needs to equal 8.4. So we're trying to figure out if this is going to equal 8.4. So let's multiply those two numbers together. This is our way to check. This would be us going from our answer, so the red triangle, back to the green triangle, multiplying by the other scale factor. Does it work? Yes. 8.3 what? 8.39?
Yeah.
That's close. That's close enough. So it equals approximately 8.4. So it works. So I have actually two scale factors here. If you guys notice, I have this scale factor and my other scale factor. Okay? So we found two of them. It depends which triangle we're coming from. If we're going from red to green or green to red. Now I'm going to show you a trick with our two scale factors. A fast way to find the other scale factor, so we call this side note. Okay? To find the other scale factor. Remember the first one we found was 2.58? Okay? I want you to think of this as a fraction. So the fraction would be like that. If I reverse this fraction, I can find the other scale factor. So it becomes 1 over 2.58. What does that equal when you divide it? Oh, look at that. That's a fast way of doing it. You could just flip the fraction, or sorry, flip your scale factor to find the reverse factor. If you're going from the green triangle to the red or the red to the green, all you have to do is flip that fraction if you need to figure it out which way or which number to multiply to go. Okay. Okay, so in your blue notebook, page 406, I want you guys to do numbers 4 to 6 right now, okay? So do those numbers in your blue notebook. Let's quickly view everything. So there's our entire page. You can see everything we've done. 1 second, John. We'll scroll down so you can see everything we did. It's all right, you can pause it when you go to rewatch it.